I am Kathiresan, Assistant Professor, belongs to the Department of Mathematics in Rathanam College of Arts and Science. Today my topic was in functional analysis. Functional analysis which is a subject to interlinked between the real analysis and to the topology. So, the topology comes from the real analysis basics. We already known about what do you mean by set. Set means set of all well defined objects. So, which is the set? The set was implemented by the subject which was called the topology. So, what do you mean by functional analysis? So, what is the purpose of the functional analysis? So, the functional analysis, how it works to the real world applications, which means that here the functional analysis is the branch of mathematics concerned with the study of the certain topological properties, and also it's technically structured by applied to the analytic problems. Which means analytic problems. What do you mean by analytic problems? In Clay of Mathematics Institute, they introduced some millennium problems. There are 7 millennium problems are there. That one millennium problem was solved, which was called the Poincare conjecture problem, which was the millennium open problem, was solved by Gregory Perlman. That was belongs to the topology. The topology also used from this functional analysis. So, here the functional analysis play a crucial role in the applied sciences as well as in mathematics also. The functional analysis has its application in every branch of mathematics, like mathematical finance and differential operators, and also the partial differential equations. So, partial differential equation means I have already told you about that. There were the 6 millennium problems are there. That was one millennium problem which was called a Navier-Stokes equation, which was also belongs to the partial differential equation. We are going to use to solve the approximation solution of this Navier-Stokes equation using this functional analysis. So, the aim of this course introduced the student to the key ideas of the functional analysis. It noted that only scratch the surface of this vast area on this course. We discussed about a normed linear space and Banach space and Hilbert space, like the Banach theorem and open mapping theorem, and also the closed graph theorem. Here the definition of a normed linear space. So, what is the definition of normed linear space? Let X be a vector space over either a scalar or a field of a complex number. Suppose we have taken a function and norm to a linear transformation x to a semi open interval 0 to infinity, such that it needs to satisfy the 3 conditions. What are the 3 conditions? The first condition is a norm x equal to 0 if and only if x equal to 0, and the second condition is norm x plus y which is less than or equal to a norm x plus a norm y for all x comma y is belongs to x, and the third condition is a norm of alpha x which is equal to modulus of alpha into a norm x for all scalars of alpha and vector x, which means that if it is a x be an vector space to mapping to the x to the 0 comma infinity, which is the function, it needs to satisfy these 3 conditions, means which is called the normed space. The first condition means if norm x equal to 0, if and only if that x will be 0. If we are taking x will be 0, that norm x should be 0. And the second condition is which was called the triangle inequality. The triangle inequality satisfied means, and the third one is norm of alpha x. While we are taking this alpha be the all scalars, while we are taking this is an example for the -1 means alpha is -1 means while we are taking that modulus, that -1 should be comes to the positive value. So, the third condition will be satisfied. The property 2 is called the triangle inequality, and the third is called the homogeneity. So, this one is called the reverse of the triangle inequality. While these 3 conditions are satisfied, so which was called the normed linear space. And the next thing, a definition of let X be a normed space over the field F means, let me look at the definition of the convergent. A sequence xn is a subset of x which is called a convergent if there exists a x belongs to the capital X such that limit xn minus x which will be 0. I am going to take an I am going to tell a real life example of what do you mean by convergent. What do you mean by convergent? While I am going to shopping, while I am going to enter the shop room, there were color of arranging the dresses. I am going to converge and I am going to pick up one dress. So, that was called the converging. You are going to converging this which dress you are going to pick up. So, which is called the convergent sequence, and thank you.